In this lesson, we are going to talk about primary trig ratios, and we're going to use these ratios to solve for unknown sides in triangles. So all triangles have three sides that can be named based on their relationship to the angles inside the triangle. Now these sides are called the hypotenuse, which you should already be familiar with, and the other two are called the adjacent side and the opposite side. The adjacent side and the opposite side change depending on what angle we are working with. So the adjacent side is the side that is next to the angle, and we call angles theta with this little symbol. It's like a letter O with a line through it, a cursive letter O. We call it theta. The adjacent side will be next to that angle. So in this diagram, the angle that's marked is this one. The adjacent side is right beside that angle. And the opposite side is the side that's across from the angle. So in this triangle, this side over here is the opposite. The hypotenuse is still the longest side and is always right across from the right angle. Now these sides could change depending on what angle I'm looking at. So for example, if I have the same triangle or similar triangle, the right angle, this side would still be the hypotenuse, no matter what. But if I then indicated that I was working with this angle in the top, then the side that's beside it or touching that angle would be the adjacent, and the side that's across from it would be the opposite. So the adjacent and opposite can flip depending on which angle we are using. Now, once we have those sides labeled, they all have a relationship. So here, if you look at these three ratios here, you'll see we've got sine of an angle, cos of an angle, and tan of an angle. So sine of this angle theta will always be equal to the length of the opposite side divided by the hypotenuse. So if I use sine of this angle, whatever this angle measures, it will be equal to this length divided by this length. Same for cosine. Cosine of this angle will be equal to this length divided by this length. And tan of the angle will be equal to the opposite divided by the adjacent. Now, sine, cos, and tan are called trig functions, and they're functions that go with the angles. They will be equal to these ratios. Now, a way to remember these three ratios is with an acronym called SOHCAHTOA. It's just a way to remember the ratios. So you'll see here that when you're using sine, you have opposite over hypotenuse, O over H, which is so. Cosine is adjacent over hypotenuse, ka. And tangent, or tan, is opposite over adjacent. So TOA. Tan, opposite, adjacent, TOA. So how can we use these ratios to enable us to solve for sides? So first, let's get some practice just setting up these ratios. So if we look at this triangle here, it's asking us to write the three trig ratios related to angle A. So I'm working with this angle in the bottom corner. If I wanted to write the three trig ratios, I should use the letter A, sine A, cosine A, and tan A, I would have to know what these sides are. So in relation to side A, which side is opposite, which is adjacent, and which is the hypotenuse. The easiest side to label is the hypotenuse. It's always right across from our right angle. So this is the hypotenuse. Now, the adjacent and the opposite, remember, can change. So according to side A, or in relation to angle A, I should say, this side, that's 27, is touching or shares a side with that angle. So that means that this is the adjacent side. And the 36 is across from angle A, so that means that it is the opposite side. So when I'm setting up my trig ratios, I can use my acronym. So, ka, toa, which helps me remember that sine of angle A will be equal to, so sine opposite divided by hypotenuse. Opposite divided by hypotenuse. And so in this case, sine of A will be the opposite, so 36 over the hypotenuse, which is 45. Now I'm going to show you what else we can do with that, but for now we're just practicing setting up the ratios. Cosine of A is adjacent over hypotenuse. So adjacent over hypotenuse. So cosine of A, in this case, is adjacent, 27, over the hypotenuse, which is 45. And tan is equal to opposite over adjacent. So in this case, we're working with tan of A instead of theta, which is just another variable. The opposite is 36, and the adjacent is 27. So those would be my 3 trig ratios for this triangle. Now in this lesson, I'm going to show you how you can start using these ratios to solve when you don't know one of the sides of the triangle. So if we look at this first example, if you had this triangle here, where you've got an unknown side, an angle of 37, and a hypotenuse that's 11, and I asked you to solve for this unknown side, what you would do is the first step is to label the sides. So in this case, because I'm working with this angle 37, I'm going to label the sides in relation to this angle. So this side underneath, the x, is the adjacent side because it's sharing one side of the angle. And this 11 is the hypotenuse because it's across from the right angle. So we've got adjacent and hypotenuse. This side over here would be the opposite. But in this case, the opposite side doesn't actually matter. We don't need to solve for it, and we don't know what it equals. So in this case, I can just ignore it. Once I've determined what sides I'm going to be working with, then I can pick my trig ratio. So in this case, I have A and H, adjacent and hypotenuse. So I'm going to look at my ratios and determine which one I want to use. Because I have A and H, it means I'm going to use cosine. So the ratio is that cosine of an angle is equal to the adjacent side divided by the hypotenuse. In this case, if I then plug in what I know, cosine of the angle, well, the angle here is 37 degrees. So cosine of 37 degrees is equal to the adjacent, which is x, divided by the hypotenuse, which is 11. So cosine of 37 is equal to x over 11. Now we need to use some algebra to isolate the x. So if we want to get x all by itself, to solve for it, we have to use opposite operations. So x is being divided by 11, so in order to isolate it, we need to multiply the other side by 11. So in your calculator, you are going to first make sure that on your screen, your calculator should say degree or it should have a letter D or DEG. You'll notice, if you can see there, my calculator actually says rad, which is a different unit. So I'm going to click the degree button. So your button will likely look like this one. And you can see here I can select degree. You need that because we're measuring these angles in degrees. And then you're going to click cosine of 37. And on some calculators, you'll see here that it puts in a bracket. You need to close that bracket and then multiply by 11. And that will give you your result of 8.78 centimeters, which means that this length here is 8.78. Now we can do the same thing in example 2. So determine the length of the unknown side and round to 2 decimal places. Now here we've already labeled the sides for you. So this is your angle of 58, and the sides have been labeled as the opposite because it's across from that angle, and the hypotenuse. So remember, the next thing I have to do is determine which ratio to use. So I'm just going to write SOHCAHTOA there. I've got the opposite and the hypotenuse, O and H, which means I'm going to use the sine ratio. So the sine ratio is sine of the angle is equal to the opposite over the hypotenuse. Now if I plug in the information that I have from this question, I get that the sine of 58, because that's the angle I'm working with, is equal to the opposite, which is y, over the hypotenuse, which is 24. Now again, just like in the question above, where I had to isolate the variable or the unknown, here I need to isolate y. So I am going to multiply this side by 24. So sine 58 times 24, and I will be left with y. Now when I do that, sine 58, make sure every calculator is different, but if it does have a bracket, you want to close it, times 24 is equal to 20.35. And I should include the units, which are centimeters. So that would be the length of the unknown side, 20.35. Now on the next page, there's a few more examples. So this one says, determine the length of the adjacent side of this triangle and round to 2 decimal places. So in this case, the sides again have already been labeled for you. So we've got an angle of 71, and then we've got the adjacent, that's unknown, and the opposite side, that's 24. So we've got, in SOHCAHTOA, we first need to pick our ratio. So opposite and adjacent means we're going to use tan. And tan theta is equal to opposite over adjacent. So when I plug in the information I know, I get tan of 71 is equal to the opposite, so 24, over the adjacent, which is our unknown. I'm going to call it x. Now, in order to solve for this one, what I have to do is I need to get x by itself. Now it's a little bit trickier to get x by itself, because if I multiply to this side, I get x times tan 71, which doesn't equal, like we can't solve that. But it is the first step in being able to solve. So I have to multiply this side by x, but then to get x all by itself, I would need to divide the other side by tan 71. What ends up happening is the x and the tan 71 end up switching places. So x is equal to 24 over tan 71. So in the previous examples, I was always multiplying, but in this side, I end up dividing. And then you're going to put that into your calculator to get a result of x equals 8.26, and these are centimeters. So I've solved for the unknown side. In the next question, you've got a triangle that's drawn for you, and again the sides have been labeled for you. So it's asking you to determine the length of the hypotenuse here. So again, the first thing you need to do is determine which ratio to use. You have opposite and hypotenuse, O and H, which means you're going to use sine. Now I can plug in what I know. So sine of the angle, sine 67, is equal to O over H, opposite over hypotenuse. So 17 over the hypotenuse, which is x. And just like in the question above it, to solve for x, we would have to multiply this side by x and then divide this side by sine 67. So these two switch positions. And when I do that, x equals 17 divided by sine 67 on your calculator, you get a result of 18.47, and these are centimeters. Okay, and the last example in this lesson is a word problem. It says, during the winter months, Kim and Bo snowmobile to each other's place. How far is it from each friend's place to the nearest town? Round your answer to the nearest kilometer. So what you'll notice in this diagram is we've got an angle of 24 degrees in this bottom corner, and we've got a distance between the two people's houses of 5.5 kilometers. And it's asking you to solve for the distance between Kim's place in town and Bo's place in town. So we're going to have to do two separate ratios. So I'm going to start with Kim. So for Kim's house, or the distance, between Kim's place and town, that's the opposite side. And the only other side that I know is the hypotenuse. So I've got the opposite and the hypotenuse in relation to this angle. So for this calculation, I am going to use sine. So sine of 24 degrees is equal to the opposite, which is k, over the hypotenuse, which is 5.5. And for this one, remember, if the variable is on top, you're just going to multiply the other side by 5.5. So sine of 24 times 5.5 is equal to k, which is 2.237 kilometers, but it asks you to round your answer just to the nearest kilometer. So just 2 kilometers. So the distance from Kim's house to town is 2 kilometers. And for Bo's house, we're going to do something very similar, but in this case, we're looking for side B, which is the adjacent. But again, the only other side that we know is the hypotenuse. So we need to use the hypotenuse to be able to solve for the adjacent using this angle. So adjacent and hypotenuse is cosine. And cosine of 24 is the adjacent, b, over the hypotenuse, which is 5.5. Again, in order to get the variable all by itself to solve for b, we're going to multiply. So cos 24 times 5.5. Which is 4.56. And again, it asks you to round. So 4.56 will round up to the nearest kilometer, and it's equal to 5 kilometers. So that's how we use trig ratios to solve for unknown sides.